All right, hi everybody. Today we're going to work through at your own pace a graphing calculator tutorial. So this is a way for you to kind of get used to the buttons on your graphing calculator, how to use them to graph quadratics, and then how to find some of the key points. So the first thing that you're going to do is you're going to take a look at this worksheet here. Notice there are two examples. It kind of guides you through step by step, but again, I'm going to go through it with you. You're going to fill this out as you follow along with the video, and then you're going to turn it into your teacher for a grade. Plus, it will be something that you can refer to anytime you're being asked to use the graphing calculator. So here, the first thing we're going to do is going to consider the equation y equals 10x squared plus 20x minus 7. Now, after being in chapter 2 for quite some time, we know that the shape of the graph for the equation above must look like a parabola that faces up. The fact that there's a squared is how we know that it should make that parabola U-shape. And the fact that there is a positive 10 out front is how we know that not only should the parabola face up, but it should be rather skinny. If you go to plug this in your graphing calculator and it does not look the way you expect it to look, it either means you entered it in incorrectly, or it means that you have to change something called the window. The window is exactly how many X's and how many Y's the calculator shows you at any given time. There is something called the standard window, and the standard window starts off with a 10 by 10. So that goes from x equals negative 10 to x equals positive 10, and then from y equals negative 10 to y equals positive 10. And again, sometimes that's a good enough picture, but oftentimes you'll have to change not only the x's or not only the y's, sometimes you'll have to change both. So that now you're going to go ahead and take your graphing calculator and you're going to go ahead and turn it on. So if you turn it on, it's possible that you have some writing here on the main screen, but if not, you have a blank screen. And this is where you can do your regular calculations, things like 5 plus 6 equals, things like 8 times 9 equals. So these are just kind of your regular commands. And the nice thing is that it shows you a couple of them all at once in case you need to refer back to the previous steps. Once you're ready to graph something, you're going to go ahead and go up to the top left corner and you're going to select the y equals. So in the y equals, it brings up lots of different y equals, 1 through 9. You usually are going to do one at a time, sometimes two at a time, but for now, let's go with one at a time. These three buttons up here for the plot, we will use those eventually, but for the time being, those should not be selected. So if for some reason they are selected, you should deselect them until your screen looks exactly like my screen. What we want to do now is we want to type in the equation on the worksheet that you're filling out. So we want to type in 10x squared. So 10, here is where you're going to find your x variable. Then you're going to choose your squared here on the left-hand side of the middle. Then plus 20, go back to your x variable, minus, make sure you're choosing the subtraction sign, 7. Double check and make sure that the equation that you've typed in is exactly the same as mine. Then go ahead and press the zoom key. So at the top in the middle, the zoom key gives you all the different options for how you're going to look at your picture. And you're always going to start off with option 6. So Z standard is the 10 by 10 grid. And if we go ahead and select that, we see sort of the parabola. We see the two arms, but we don't really see where the vertex is. And it's really not just the best picture. So we're going to have to go ahead and change our window. It looks like from left to right, we have enough X's to see what's going on, but going from bottom to top, we don't really have the whole picture of the Y's. So when you go ahead and press the window button, here's where you can, if you want to, change some of your values. So again, the X's looked okay, so we're going to leave that from negative 10 to 10. And then the X scale, that means how much do you want it to go up by for each tick mark. Usually you'll just leave it at 1, so we'll go ahead and leave it at 1 for now. When it comes to the y values, again, we didn't really have a good enough picture of seeing exactly how far down the parabola went. So we're going to change our negative 10 to something like negative 20. Maybe you would change it to negative 15, maybe negative 25. You'll get better at changing the window the more of these we do. But for now, let's try negative 20. We'll know right away if that's not a good number. And then we'll leave 10 for the maximum. We'll leave 1 for the y scale. And don't really worry about the other stuff for now. If we want to see if this is a good picture, you can always go back to the top right, which is the graph button. This will now show you the picture with the new window. And as you can see here, it looks much more like we're expecting it to. So if you go back to your worksheet for a second, I have already drawn for you the graph. Again, you have to make sure that you change the window until it looks exactly the way that you were expecting. And then we're going to go ahead and remind ourselves what were the X values that we chose and what were the Y values that we chose. So that means the window. So for the X values, we chose -10 to 10. And I'm going to use brackets because I was including both those numbers. Then for the Y values, we changed the lowest Y value to -20, and we left the maximum value at 10. So it's just kind of good to have a plan at the beginning, think about how big or how small you need those values to be. So -10 to 10 for the X's, and then -20 to 10 for the Y's. Now they're asking you to find and label the y-intercept. So we can find the y-intercept actually quite easily from this equation. Of course, you should be able to recognize that this is an equation in standard form. In standard form, the y-intercept is always, of course, 0, c, which in this case would be 0, -7. If we go ahead and look at our picture, we can label the y-intercept right here. This is the point 0, -7. In terms of how you would find that value on the graphing calculator, there's a couple of different options. So if we go back to the graphing calculator, the first place that you can find the value not only for the y-intercept, but for any value is by looking at the table. You'll see the word table is written above the graph button in another color. That blue color means you have to first press this blue button in order to get the table to pop up. So you're going to press second, graph, and that's going to bring you up your table. Now, your table should look different than mine. It should show you lots of values. Mine only shows a few because I have it set in a certain way, which you don't have to worry about. But basically, you would look at your X's and you would scroll up and down until you got to X equals 0. Once you got to X equals 0, you would be able to see that the corresponding Y value is -7. So you could be 100% sure that that was the value 0, -7. Now, as you can see, the X's continue to go on, usually counting by a step of 1. If your values are counting by some other step, then you'll need your teacher to help you kind of reset your calculator to be 1. But for the most part, again, you should see all the possible X's counting in values of 1. So that's one place where you can find values that you're looking for. The downside is, what if you wanted to find a very large value, like 100? You certainly don't want to sit there and have to scroll through all those values. So as we go back to our worksheet here, another option for how you find values is that you can find and label ordered pairs that exist for specific values of X's. So we are specifically looking for the point -2, comma something, and the point 5, comma something. Now, those values aren't particularly large, so it wouldn't really take you a long time to scroll for them, but I'm going to go ahead and show you another option. So in order to find this option, you're going to press second, and then you're going to press the trace button. So this is going to bring you up what's called your calculate menu, and this is the majority of where our commands are for today. But you're going to go ahead and select option 1, saying that you would like the graphing calculator to find for you a specific value. You can now enter in whatever X you want, and it will immediately tell you what the corresponding Y value is. So the first X value that I had asked you to choose was -2. If you go ahead and plug that in and press enter, looks like I pressed the minus instead of the -2, so that's my mistake. So down here next to the enter key, you're going to choose the negative button, common mistake. Make sure you choose the negative, not the subtraction. 2, when you hit enter, it's going to tell you that that is the point -2, -7. So back on our sheet here, this is -2, -7. You're going to go ahead and locate that point. So -2, -7. That would be this point right here. Now we want to find the Y value at 5. So go back, press your second trace button. Again, choose value. We are going to choose a value of 5. Hit enter, and that is 343. Now, obviously, when we go back here, that value is going to be significantly off the picture, which is perfectly fine, but 343. Now we would like to find and label the coordinates of the vertex. And a new vocab word is the fact that this is considered to be what's called the minimum, meaning it is the lowest possible point on the quadratic. Whenever you have a parabola that's facing up, the vertex will always be the minimum. Whenever you have a facing down parabola, then your vertex will always be the maximum. So yes, we know the formula -b/2a, but the whole point of the graphing calculator is a little bit of a shortcut. So if you go back again here to your graph, You're going to use that same set of commands, second, trace. Again, your calculate menu here brings up the majority of what we're looking for. And in this case, because you're looking for the lowest possible value, you're going to choose the minimum. So now your calculator is going to ask you for something called the left bound. So you need to locate your cursor. So see how at the bottom my numbers are changing? That's because I'm moving my blinking cursor from left to right. You'll know if you need to move it from left to right, whether or not the values are getting smaller or larger. You basically want to get very close to where the vertex is. And of course, the vertex is that minimum point there. When they say left bound, it means you want to get close to the vertex, but you want to stay on the left side. So exactly where my blinking cursor is right now doesn't even have to be that close. That's a perfectly good estimation for the left bound. So I'm going to go ahead and hit enter, and you'll see it draws me a little dotted line there. Now it's going to ask me for the right bound, so I have to scroll to the right of where the vertex is. Again, you don't have to be too close, just don't be too far, and then I'm going to go ahead and hit enter. So what you're telling the calculator is to find the minimum value between those two bounds. You can guess if you're fancy, which means scroll really, really close to where the vertex is. I usually just skip that step, hit enter one more time, and it will tell you exactly where the location of the vertex is. So negative 1.000001, you can safely assume that that's negative 1 and negative 17. So we're going to go ahead back here, and the location of our vertex is negative 1, negative 17. So we're going to go ahead and label that on our graph. And then notice that those 2 points that I had found previously, 0, negative 7, and 2, negative 7, that's the y-intercept, and then the reflection point on the other side. Remember, of course, that if I was to draw in the axis of symmetry, that would be the vertical line that goes right through the vertex. So there should, of course, be mirror images on each side. Last but not least, the most important thing that we want to be able to find are the coordinates of the x-intercepts. Your graphing calculator calls those points the zeros. Those two things mean the exact same. The x-intercept is, of course, where the graph crosses the y-axis. So if you look carefully at where y equals 0 is, we can see that there is an x-intercept here, and we can see that there is an x-intercept here. That means that there is one positive answer and one negative answer, and we're going to go ahead and find both. So when you go back to your graphing calculator, again, second, trace, you're now going to choose the 0 option. Again, that means x-intercept. Because there are two zeros, you're going to have to do this process twice. Doesn't matter which one you start with. Let's just go from smallest to largest. So as you get closer and closer to where the x-intercept is, when they say left bound, it means you have to be to the left of where that point is. So in this case, it means you have to be somewhere above where the x-intercept is. So that's a pretty good estimate. Then you have to go and find the right bound, which just means you have to be somewhere to the right of where that x-intercept is. Again, guess if you're fancy. Usually I just skip that step, and that's going to give me the following. Take a note here of the y value. So the y value of negative 1, e negative 12, that is scientific notation. That means negative 1 times 10 to the negative 12, which would be 0.000000001, which is essentially 0. So if you see that value on your calculator, it just depends on how your calculator is set for rounding. But whenever you see that value with a really big e to the negative, that means it's just 0. So negative 2.3, that is the value of one of our x-intercepts. So we're going to go ahead and add that in, negative 0.23, comma 0. Now we have to do the process one more time. So again, second, trace, choose the 0 option. Now we have to find the second answer. So when we say left bound of the positive answer, the left bound means you have to be underneath it. Then you have to scroll so that you're above it, if you're fancy. Otherwise, hit enter again, and you see you get positive 0.30. So that is our second x-intercept. And those two answers should always have a relationship because, again, they should always be symmetric over the axis of symmetry. So the fact that it's negative 0.23 and, I think it was negative 2.23. Sorry about that. Oh, no. Negative 2.30. Sorry. So 0.30 and negative 2.30. Let me try to find my eraser here just to make sure that's clear. All right, so negative 2.3 comma 0. And I had it graphed correctly. I just had written that down wrong. So sorry for that. All right. So again, the whole point of this lesson is to make sure that you can use all the buttons on the graphing calculator. So let's go ahead and do one more together before you go ahead and try some on your own. So notice here in the second problem, you have a rather ugly looking equation. As we move into the word problems, we are going to be seeing these kind of ugly looking equations, which means more than likely we are going to have to be changing our window. So go ahead and go back to your graphing calculator. Go back to the y equals. You're going to go ahead and delete or clear whatever you have there in y1. You're now going to type in your second equation. And again, do it very, very carefully. When you're choosing in the negative, make sure you choose the negative, not the minus. So next to the enter. Then 0.075. Make sure you have the 0 and the decimal point in the right spot. Here's your x. Here's your squared, plus 9x plus 450. Again, usually when you want to see the graph for the first time, you press zoom, you go to zoom standard, and you see what, if anything, shows up on your screen. Now, in this case, I don't see anything. Because I typed in the y equals, I know there should be something there. So the fact that there isn't means that I have to change my window significantly. And if you look at the equation, the fact that this is in the hundreds means that my window might have to be pretty large. So in terms of the x's, again, I'm not really 100% sure what it's going to look like. So I'm going to go to negative 100 just to be sure. And then for my x maximum, how about we choose positive 100? Then for the y minimum, let's try to keep it the same. So negative 100. And sorry, again, I have to, it's a little different on my computer. So negative 100 and then positive 100. And if you want to see whether or not that is a good window, you're going to go ahead and press graph. As you can see, we can only see part of the parabola. We cannot see the whole thing. So because of the fact that it's upside down, looks like this is the left half. So we're going to need more positive x's and we're going to need more positive y's. So go back to your window. Your x maximum is not big enough. So 100 is not enough. Maybe we'll try 200. Then for the y's, we need some bigger y maximum. So maybe 200 will be enough. Let's try 500. Make sure that your minimum is always smaller than your maximum, or else it's going to tell you that you have an error. Press graph one more time. Ooh, looks like we're getting much better here, but the y's still are not quite good enough. So 500 is not enough. Let's try 600. And then when we press graph again, looks like we're still not quite there. So let's do an even bigger jump this time. Why don't we go ahead and go up to 1,000? Then let's go ahead and press graph, and it looks like that gives us just enough. So again, because of the fact that this was y equals negative something x squared, is how I absolutely know that it has to look upside down. So as I go back to my screen here, what were the x values that I chose? So I decided to do negative 100 to 200. And then for the y's, I believe I did negative 100 to 1,000. And again, it always just helps to write down what your window was so that when you go back later, and then here on the screen, obviously you see the correct picture. I had already done that for you and gave you a snapshot. That way you'd be able to label the important stuff. So labeling the y-intercept, again, because this is still standard form, I can feel 100% confident that my y-intercept is going to be 0, 450. And if I label that, that must be where it crosses the y-axis, which would, of course, have to be right here. So 0, 450. And again, as a reminder, if you want to find that point on the graphing calculator, you can either do second graph, which brings up your table. And then if you go to 0, you'll see 450. Or you can use the value keys, which is what we're going to do to find the values at 30 and 100. Obviously, you can see why scrolling through your table for those values would be kind of a waste of time. It would take you a while. So back to the calculator, you're going to press second trace. You're going to choose value. The first value was 30. Hit enter. Turns out that that has a value of 652.5. So let's go ahead and graph that on here. Or we can graph that after. So 30 and then 652.5. In terms of how much should you round to, we'll get into that as we get more into the word problems. For now, it doesn't matter so much. Then go back, second trace. You're going to choose value. You're going to choose the second value, which was 100. And the y value is 600. And sometimes they wind up being nice whole numbers and sometimes they don't. And either one of those is fine. Because of the fact that you have a parabola that's facing down, your vertex in this case, negative b over 2a, is not going to be the minimum, but it is instead going to be the maximum. So when you go back to the graphing calculator, you're going to press second trace. Now make sure that you choose maximum. And again, it's going to ask you for the left bound and the right bound. So the left bound means you have to be close to the vertex, but to the left of it. The right bound means you have to be close to the vertex, but to the right of it. Guess if you want, otherwise pressing enter one more time will give you the answer. We'll go ahead and assume safely that that is 60, 720. All right, finally, you're going to want to go ahead and find those x-intercepts. And actually the vertex, we can go ahead and add to our graph since we're 100% sure where that is. So 60, 720. Then we want to go ahead and find the value of these two x-intercepts. Again, one is positive and one is negative. It's possible that they could both be negative or they could both be positive, but in this case, there happens to be one of each. So back to your calculator, second trace. Remember, an x-intercept is called a 0. Doesn't matter which one you start with. I'm going to go ahead and start with the negative one. So when they say left bound, you have to be to the left of the answer, which in this case means you have to be underneath the x-intercept. Then when they say right bound, you have to be above the x-intercept. Hitting enter 2 more times will give you the answer of negative 37.979. So let's go ahead and call that negative 38. And again, comma 0. One final time, second trace, that's going to give us a 0. We're now going to have to scroll all the way over to the positive answer. So when you're trying to find the positive answer, your left bound means you have to be above the answer, and your right bound means you have to be below the answer. And it looks like the answer here, so 158, let's round it to. And again, that negative 1 e to the negative 10, that's just a very fancy way of saying 0. So we'll go ahead and call that 158, 0. All right, and then if you want to just go ahead and add in those two other points that we found earlier. So the point 30, 652, that should be exactly between x equals 0 and x equals 60. So 0, 652, a reasonable estimate of that would be about halfway between. So 1, 2, 3 is 60. So about halfway between here, that would be your reasonable estimate for the point of 3,652.5. And then you want to go ahead and estimate 100, 600. So again, you're going to find what you think would be a reasonable estimate for that. So this is 158, this is 60. So you're going to go ahead and just count a couple of intervals over, and you're going to go ahead and estimate 100, 600, which would probably be about here. So you can refer back to this worksheet at any time if you're looking for a reminder of how to do these commands. Your teacher should also give you a set of just directions for all the graphing calculator commands. So congratulations, that was your very first attempt probably at using the fancy buttons on the calculator. So thanks very much for tuning in, guys, and we will catch you next time.